everyone. Thank you very much for watching my live stream. I'm Mr. Matt, and this is Dr. Tot. Dr. Tot, do you want a cookie? Oh, you sure? There you go. And welcome to Algebra 1. We're going to continue our preparation for the Semester A exam. This is Part 6, the live stream to Part 6. Remember that I want you to use these live streams in addition to the Practice Exam 1 as diagnostic tools to identify areas in which you might need to improve. You can then go to the independent practice problems and the quick drill sets that will be posted soon for each of these videos in order to reinforce your skill sets. So the independent practice problems are going to be a larger activity with varying difficulty. The quick drill sets are going to be shorter but more advanced problems and concentrating on word and real life scenarios wherever possible. So look those things up if you find anything in this stream that you find uncomfortable or a little bit confusing. I'm also available always for any questions that you have. If you're watching live, you can drop your question into the live chat feed. If you're watching the recording, then you can always contact me in the comment section below, or my social media accounts are all listed and linked in the description. So if you have any questions or you have any recommendations for videos, feel free to hit me up there. If you find these videos helpful, please like, subscribe, and share with your friends. I appreciate it very much, and welcome to all the new subscribers. Let me go ahead and share my screen with you. And just a reminder, these are live streams, so there's a little bit of a delay with the iPad, but I'm going to mitigate that as best as I can. So today we're going to be looking at writing equations using ratios, solving proportions, matching graphs to real life scenarios, and identifying domain and range, as well as linear versus nonlinear functions. This document that corresponds to today's lesson is going to be posted on Certified Learning Center's website. The link will be in the description below. Just make sure that you have the document with the reference number 1949-24, and then you know that you're in the right place. I'm circling it right there. And again, if you have any questions, then just please let me know. Otherwise, let's jump right in and look at question number 1. Question 1 asks, write an equation to model the following scenarios and solve for the missing value. So 1A is asking, 3 business partners are splitting the profit of a new project in a ratio of 2 to 3 to 5. If the total amount of profit from the project is $1,000, what is the least amount of money any one of the partners made? For question 1B, it's asking if 3 angles of a triangle are in a ratio of 2 to 3 to 5, what is the measure of the smallest angle? So I'm going to give you 4 minutes. After 1 minute, I'll start to solve to give you some hints. I'm going to keep track of the time in the upper left-hand corner, and I'll try to the best of my ability to update it per minute. But after 1 minute, again, I'll start to solve to give you some hints. Okay, so there's two general ways to approach word problems like this that give you ratios and then the total amount or the total sum of all of the components that the ratio elements collectively represent. And that is, one, you can either write an equation directly that represents the sum in terms of some variable x that represents the common multiple between the ratio elements. In other words, you can take the numbers in the ratio and just represent them in terms of x, add them up, and set it equal to the sum that it's supposed to be, or what they tell you that it is. So if they tell us that the profit of this new project is going to be shared in a ratio of 2 to 3 to 5, then we can say that 2x plus 3x plus 5x is equal to $1,000. Or in other words, 2 times some common multiple that we're calling x, plus 3 times some common multiple that we're calling x, plus 5 times some common multiple that we're calling x is equal to 1,000. That allows us to collect like terms, so 10x is equal to 1,000. So the common multiple here is equal to 100. Dividing by 10 on both sides, we get x is equal to 100. Now x is not the answer. X is the common multiple. You have to substitute that common multiple back into the expression that represents the individual component that the question is asking you about. So here, they want to know what the least amount of money any one of the partners made. Well, the expression that represents the smallest share of profit out of 2x, 3x, and 5x would be 2x. If we evaluate 2x with the common multiple of x is equal to 100, we get 2 times 100, or 200. So 200 is the answer to 1a. But I also wanted to explain the separate method that you could use to solve here. Remember that ratios are just the comparison of numerators, the numerators of fractions that have the same denominator. So you can immediately convert any ratio element into a fraction by taking the ratio element as the numerator and then adding up all the ratio elements to get the denominator. So the smallest share of this business venture, the numerator would be 2, because that's the ratio element that represents the smallest share in the 2 to 3 to 5 ratio. So 2 is the numerator. The denominator would be the sum of all the ratio elements. So 2 plus 3 plus 5 is 10. So the smallest share represents 2/10 of 1,000. 2/10 of the total $1,000 of profit is $200 of profit. So there's two separate ways of thinking about these problems, and I wanted to give you both are valid, and it just depends on personal preference and then also sometimes the context of the question as to which is should be the preferred method. But if you have any questions on either of the methods, then please let me know. For 1b, here we have to know that the sum of the interior angles of every single triangle has to be 180. So if they give us the ratio in which these interior angles are in, we know that the sum has to be equal to 180. So if we use the first method, we can represent each ratio element in terms of x, sum them together, and set it equal to 180 degrees. So we get 2x plus 3x plus 5x is equal to 180. So 10x is equal to 180. Dividing by 10, x is equal to 18. If x is equal to 18, that's the common multiple that we need to evaluate by substituting into the expression that represents the characteristic that the question's asking about. Here, they're asking what is the measure of the smallest angle. The expression that represents the measure of the smallest angle is 2x. So 2 times x, or 2 times 18, is 36 degrees. So the answer to 1b is 36. If we use the fractional analysis method, then we could determine that from the ratio of 2 to 3 to 5, the smallest angle has to be 2 over 2 plus 3 plus 5 as a fraction, or in other words, 2/10 of all the degrees in the interior sum of the angles. So 2/10 times 180 is also 36. If you have any questions, then please let me know. Otherwise, let's look at question number 2. This is going to involve solving proportions. So remember, anytime a proportion is the comparison of two ratios, two rates, or two fractions to each other. So anytime that you have two fractions or on opposite sides of an equal sign, there's a special operation called cross multiplication. So you can multiply the numerator of one side with the denominator of the other, put that product on one side of an equation, and then put the product of the other two components on the other side in order to simplify overall and then solve. So I'm going to give you 3 minutes. Please solve for the missing variables in the following equations. Or proportions rather. A is x over 4 is equal to 5 over 10. B is 2 over 3 is equal to m over 9. And C is 6 over a is equal to 3 over 4. I'll give you 3 minutes, and 1 minute in I'll start to solve. Okay, so for 2a, we can cross multiply here. A trick, it doesn't really matter here if we're using an equal sign to separate the two fractions. However, in later math classes or in more advanced math classes, you might see an inequality on opposite sides of an equal sign. And one good habit to get into is when you cross multiply, to keep the location of the numerators the same, or to keep them in the same position. So here x is starting off on the left side, so it's good to keep it on the left side. Like I said, it doesn't matter if they're equals, if they're proportions, but later you might see inequality signs here, and that doesn't say that one side is equal to the other. It says that one side is greater or less than, or greater than equal to, or less than or equal to, and so it will make a difference there. So a good habit to get into is that numerators never change sides. So here we're going to get, when we cross multiply, x times 10 is equal to 5 times 4. So we're going to get 10x is equal to 20. Dividing by 10, x has to be equal to 2. For 2b, if we have 2/3 is equal to m over 9, cross multiplying, we're going to get 2 times 9 is equal to m times 3. So 18 is equal to 3m. Dividing by 3 on both sides, m is equal to 6. And 2c, we have 6 over a is equal to 3 over 4. So cross multiplying, we're going to get 6 times 4 is equal to 3 times a. So 24 is equal to 3a, and then dividing by 3 on both sides, we're going to find that a has to be equal to 8. If you have any questions, then please let me know. Otherwise, let's take a look at question 3. Question 3 is going to ask you to match the following scenarios to the correct graph. So I have 2 scenarios and then 3 graphs. So one of them obviously is, one of the graphs will not be used. Question 3a. So a ball is thrown in the air and 5 seconds later it hits the ground. Which graph represents the distance the ball is from the ground as a function of time? 3b is asking, a marble is rolled, and after 3 seconds, the marble is 12 feet from the starting point. Which graph represents the distance the marble is from its starting point? And I should say as a function of time. I'm going to give you 3 minutes, and then we'll review. Okay, so for 3A, when a ball's thrown into the air and then 5 seconds later it hits the ground, we would expect there to be zero height. Well, practically, I mean, technically there would be a difference between the height that the person, when the ball left the person's hand and the ground, but let's just assume for practical sense that that's not the case. So we'd have a zero distance at x is equal to 0, and y would be equal to 0 when x is equal to 5. So at 0 seconds, we would be 0 feet from the ground because the ball hasn't left yet. And at 5 seconds, we would be 0 feet from the ground because it's back on the ground again. And in between, we would expect the height to go up. It would peak somewhere in the middle and then start to decline as gravity pulls the ball back down to the ground. So the graph that represents that would be A. Notice that that is not a linear function because the rate of change, the speed at which the ball is traveling, is changing, and then also the distance from the ground is negating. It changes direction. It's going to go up and then it's going to fall back down. So that's graph A. For question 3B, when the marble is rolled and 3 seconds later the marble is 12 feet from the starting point. So notice that even though graph C goes beyond 12 feet, it goes beyond 3 seconds, we have a constant rate of speed, and at x is equal to 3, y is equal to about 12. And so that represents the correct relationship between the distance the marble is from the starting point and time. As time increases, we would expect the distance the marble is from the starting point to continue to increase as well, but continue to increase at a constant rate. And that's different than 3A because that doesn't have a constant rate of change. At first, the acceleration from pushing the ball up is going to be very, very high, but then as the ball peaks towards its maximum height, maximum altitude, gravity is then going to start pulling, or as soon as you let go of it, gravity starts pulling the ball back towards the earth, which is going to slow the rate, the velocity of the ball. So that's what you're seeing happening in graph A, and 3B is depicted in graph C. If you have any questions, then please let me know. Otherwise, let's look at question 4. So question 4 is a little bit of a combination here. So we're going to identify first whether the graphs or the equations listed or equations, so you're given both. Some of them are equations, A and B are equations, C and D are graphs. You have to identify whether they're linear or nonlinear, and then I'd like you to state the domain and range for each of the functions. I'm going to give you 4 minutes. After 1 minute, I'll start to solve. Okay, so first let's identify linear versus nonlinear. So linear is a constant rate of change. You can most easily identify that by looking at the equation by determining if the equation has any exponents or not. So for 4a, you can see that we have an x and a y, but they're all just implicitly raised to the first power. We have no higher powers than 1 there, so that's a linear equation. From the graph, 4c is linear because we have a straight line. So linear equations will always produce straight lines. 4b and 4d are not linear because 4b contains an exponent on that x. We have a 3x squared, not just a 3x. And then for 4d, you can see that the slope is changing there because you don't have straight lines. It's bent, and it actually reverses direction and makes that characteristic U shape of a parabola. So A and C are linear, B and D are nonlinear. Now for domain and range, domain is the acceptable x values or the x values that the function will obtain, and the range is the y values that the certain function will obtain. So for domain, you're looking left to right. For range, you're looking bottom to top. So left to right for A, if you're given the equation, it's most helpful to either isolate for y into either the slope-intercept form if you're talking about a linear equation, or vertex form if you're talking about a parabola. So for 4a, I simplified that in the blue ink. And so if you subtract away the 6x on both sides, you're going to get 3y is equal to negative 6x plus 12. And then dividing by 3, you're going to find y is equal to negative 2x plus 4. So you can see that that's a constant rate of change. We have a constant slope, and we have no no exponent values. And so this guy has a y-intercept of positive 4 and is going down 2 for every 1 right. So this is just a linear line. All linear lines are going to have, unless they have some type of discontinuity, which we'll learn about in the future, unless they have some type of asymptote or hole in them, then the domain and range would be all real numbers. Now it matters whether you're asked to input this using bracket notation or whether you're allowed to just use the symbol. That kind of weird double R symbol represents all real numbers. So that's a shortcut to writing it. Otherwise, you'd need to use parentheses if you're talking about infinity. Infinity is not an actual explicit value. It's more of a concept. So you can never achieve infinity. So you have to use parentheses instead of brackets. So the domain of this function is all real numbers, negative infinity to positive infinity with parentheses. The range is also all real numbers, negative infinity to positive infinity, because as we will infinitely be able to go right, infinitely be able to go left, this function will infinitely go down and infinitely go up. For 4b, however, this is nonlinear. This is actually a parabola, and I sketched it out there. And you can go about sketching these types of graphs by first isolating for y and putting the function into vertex form. So vertex form is y. There's a little bit of a delay here, but I'll write it below in red. Y is equal to a times x minus h quantity squared plus k. So understanding what this vertex form means will allow you to visualize what the parabola looks like. A is a stretch or a shrink factor. Here we just have -1 for a, that value outside of the x in simplified form. So when we have a negative value for a, that just means it doesn't stretch or shrink it. It just flips it all around the x-axis, so it's going to be opening downward. So a is a stretch or shrink factor. H is your horizontal shift, or the x-coordinate of the vertex. And k is your vertical shift, or in other words, the y-coordinate of your vertex. So here, when we look at the equation in simplified form, y is equal to negative x squared plus 3. you can see that there's no horizontal shift and there's a vertical shift of +3. However, there is a flip around the x-axis, so we're opening downward, and our vertex is at 0, 3. So that's how I just made a rough sketch here. You can see, therefore, that this is not linear, and the domain is all real numbers because we were infinitely be able to go to the left, just as we were infinitely able to go to the right. However, the range is going to be negative infinity with the parentheses, because we're talking about infinity there, comma, 3 close bracket. With the 3, we need to use a bracket instead of parentheses because we're talking about a finite value, a finite maximum value of which there is a limit to the function. So the maximum value of this parabola we can see as a y value of 3, indicated by the vertex there. So we can go anywhere negative all the way to negative infinity, but the function will never go higher in a y value larger than +3. For question 4c, this guy is obviously a linear line. Linear lines have all real numbers as their domain and range because we can infinitely go left, infinitely go right. We can also infinitely increase and infinitely decrease. So the domain and range for 4c is all real numbers. For 4d, however, this is a nonlinear function. You can see that because it's not straight lines. It's kind of a conglomeration of different line segments. However, the domain is all real numbers because we can infinitely go left and infinitely go right. However, there is a restriction on the y coordinates. We have a minimum of y is equal to 0. And so we can go infinitely positive, but we can't go below y is equal to 0. So the range for this function is bracket 0, comma, positive parentheses, positive infinity, parentheses, closing parentheses. So that's going to take us up to the end of class today. I don't want to start something that we won't have enough time to finish, so I'm just going to end here. So we got some exposure, one example of each of the subtopics that we were going through today. Look out for the independent practice problems as well as the quick drill sets if you'd like additional practice with any of these. And as always, I'm available on my social media accounts as well as the comment section below if you have any questions. Otherwise, Dr. Tot, do you want to say goodbye and get a cookie? A cookie for end of class? Oh, yes. We're ready, huh? You say bye? That's tongue. That's your tongue. Goodbye. Say bye. Okay. All right. Very good. All right. Thank you guys very much for watching. I hope you have a wonderful night. If you like these videos and they're helpful, please like, favorite, and subscribe to my channel. Again, I'm Mr. Matt. I hope you have a wonderful night, and I'll talk to you all tomorrow.